Today we will talk about structure of atom. So what is an atom? An atom is the smallest particle of matter which may or may not exist independently. But atom is the smallest particle. It was concluded by Dalton. Dalton gave Dalton's atomic theory in 1808. There he concluded that atom is the smallest particle capable of participating in a chemical reaction. But actually, an atom may or may not exist independently. Now later on, around at the end of the 19th century or in the beginning of the 20th century, scientists like Thomson, Goldstein, Chadwick, Rutherford, Bohr, they all concluded that atom is divisible. It is made up of many subatomic particles, and out of them electron, proton and neutrons are the fundamental particles. So that means every matter is made up of these tiny particles called atoms. And atoms are electrically neutral, but surely they carry some charge, which is because of the subatomic particles present in them. So let's begin the discovery of first subatomic particle, that is electron. Now electrons were actually discovered by J.J. Thomson, but it was discovered during the Crookes experiment. So Crookes, he designed a tube, a hard glass tube about 60 centimeter long, and conducted an experiment in 1879. That experiment was based on the conduction of electricity through gases at low pressure. So what he did, he performed the experiment in a discharge tube which is almost 60 centimeter long, made up of hard glass, and it had the two electrodes, cathode and anode, and they were present in the sealed tube, means the tube was sealed from both the ends. These electrodes were further connected to a source of high voltage, that is high tension battery or induction coil. Now the tube had a side extension, a side tube. That side tube is connected to the vacuum pump. So what he did, he took the gas into the test tube, the gas under study that was filled in this hard glass tube, and the pressure can be reduced in this tube with the help of the vacuum pump. But how the experiment was conducted in this discharge tube? In this discharge tube, the gas under study was filled and few observations were taken. The very first observation was under normal pressure, that is 1 atmosphere. Nothing was observed. Even when the high voltage of about 10,000 volts was applied, even then the gas did not conduct, because we know that air is a poor conductor of electricity. Then the pressure was reduced. How? By using the vacuum pump. When the pressure was reduced to about 10 raised to the power minus 2 atmosphere, the gas was found to emit certain light. Now the color of the light, it all depends on the nature of the gas taken in this discharge tube. Then again the pressure was further reduced to 10 raised to the power minus 4 atmosphere. At such a low pressure, the walls of the discharge tube opposite to the cathode started glowing with a faint greenish light called fluorescence. Now, how it was concluded? Because behind the anode, some zinc sulfide material was coated. Zinc sulfide material is fluorescent by nature. Means whenever some charged particle striked at such fluorescent material, they produce a glow. Means a glow is produced on this zinc sulfide screen, indicating that some charged particles have bombarded on that surface. So this experiment simply showed that Fluorescence is due to the bombardment of the glass wall of the tube by the rays which were generated at the cathode. Since the rays were generated at the cathode, so these rays were called cathode rays. So what was the origin of cathode rays? How these radiations were generated? Number one, the first thing was, it was the material of the cathode from where the first electron came out due to the high pressure. Due to high voltage applied on this experiment, the first electron came out of the cathode material itself. And number two, the beam of the electrons were generated. But how? That beam of electron was generated because due to the bombardment of that electron which originated at the cathode, the gas got ionized inside the discharge tube. Once the gas got ionized, electrons were generated. These electrons again struck at the atom and they again generated the ions as well as the electrons. So in this way, the electrons were generated and they started moving from cathode towards the anode. That's why these radiations were called cathode rays. So cathode rays are the rays which travel from cathode towards the anode, and they are made up of negatively charged particles. So what was concluded from this experiment? Number one, the cathode rays start from cathode and move towards the anode. And these rays were not visible, but their behavior could be observed with a certain kind of material called fluorescent or phosphorescent material. Now, in detail, what happened, that anode was made perforated, and behind the anode, the hard glass tube was coated with zinc sulfide material. This zinc sulfide material is fluorescent, means whenever some charged particle will come and strike at the surface, it will be producing a glow. So that's why when the experiment was conducted, some particles they struck at zinc sulfide screen, and it concluded that there are some charged particles present in these rays. Now, there are some more points to be discussed under the results. That is, in the absence of electrical or magnetic field, these lines they travel in straight line. And in the presence of the electrical and magnetic field, the behavior of these rays were similar to that expected from negatively charged particles, suggesting that cathode rays consist of negatively charged particles called electrons. Now, what are the properties of cathode rays? Number one property of the cathode ray is these rays travel in a straight line. So, whenever a solid subject or any object is placed in the path of the cathode ray, it casted its shadow, which simply indicates that these rays travel in straight line. Number two, cathode rays are made up of material particles. For example, if we place some pedal at their path in between their passage, and that light pedal or light wheel will start rotating, simply indicating that these are the material particles. Now they consist of negatively charged particles. How? When these rays were subjected to the external electrical field, they were deflected towards the positive plate. These rays produce heating effect. When these rays strike at some metal foil, they will be producing heating effect. Now cathode rays, they produce X-rays when they strike on the surface of hard metals such as tungsten, molybdenum or even copper. Cathode rays, they can pass through thin foils of metals like aluminium. But yes, of course, if the foil will be very, very thick, they will be stopped by that foil. These rays, they ionize the gas through which they pass. And cathode rays, they strike against a glass surface or a screen coated zinc sulfide, then they produce fluorescence, that is glow.